Does anybody know that Jason Statham film where he needs to keep taking drugs to keep going? This talk might be a bit like that, but with cough medicine instead. So I'm here to talk about solid structure, how to theoretically build decoupled applications with using an injector. For anybody who doesn't know what the solid in the title of this talk is referring to, the solid principles are suggestions of how you can write good code. If you don't recognize these or aren't familiar with all of them, they can be your homework for the evening. And apologies in advance. I normally try to make my talks start off easy before getting harder. There's a small chance I may have failed with this talk. If I completely lose you right from the start of the talk, it's not your fault, it's mine. When I was doing a run through yesterday, I just realised that the start of the talk might be a bit confusing, and then people might find the rest of the talk a bit difficult to follow as well. This chap called JB Rinsberger has a video of him giving a talk called Integrated Tests Are a Scam. If you don't understand anything that I'm talking about this evening, I suggest watching that talk. It'll make the stuff that I'm talking about a lot more easy to understand, hopefully. So we'll get into solid structure in a moment, but first something slightly a bit different. Oops. Technology. So my background is in physics and chemistry, and with that we're trying to understand what really is happening in reality. So started at school, you learn about solids, liquids and gases. You go to secondary school, you learn about molecules and atoms. And then you go to university, you learn about fundamental particles, like such as quarks and leptons. And then finally you go in later years at university, you learn about the fundamental forces, which gravity, electromagnetic forces, strong and weak nuclear forces. It's almost 20 years ago to the day I was sitting in a lecture hall in Nottingham University on Monday morning at 9 a.m. in a lecture about quantum physics, when I realised a couple of things. First of all, whoever schedules a 2-hour quantum physics lecture for first thing on a Monday morning is not a nice person. Second thing is that actually quantum physics is actually a tiny bit hard, and that maybe going away after university to make video games would be a much more sensible thing to do, rather than trying to understand physics that gets a bit too complicated. But the third and most important thing was that most of the time, really going down into the detail of what is happening at a fundamental level just isn't that useful. If you're going to be building a house, you don't really need to know how the strong nuclear forces of the atoms are interacting with each other. You just get some wood, get some bricks, put your house together. So most of the time, thinking at higher levels of abstraction is a much more useful thing to do. And the same thing is true with programming. We normally think of high-level things like what language should we be using, what frameworks should we use versus individual libraries, whether we should be using procedural or object-oriented code, or whether functional programming versus code that works is a good thing. Those are the high-level things in programming, but they aren't the fundamental ones. Most of the time, those are the good things to think about, but sometimes you need to break it down and just really think what is actually going on at a fundamental level when you're doing programming. And to me, there's actually just about two fundamental forces in programming. They are, can code be unit tested? So there's code that can be unit tested, and there's code that can't be unit tested, which is the main topic of this talk. But the second one, which I will just cover very quickly, is whether you have semantically meaningful types versus basic types like string or an int. So to try and explain what I mean by this. So we've got this diagram It's trying to be a representation of an application that does something like send notifications to Twitter. So, sorry, people at the back can't read that at all. On the left side, it says bootstrap.php, index.php, which are then connected to a layer of controllers, which are then probably connected to a layer of services, which then are connected to we have code that actually calls external services. So that's kind of the application I want you guys to be thinking about. So some sample code that would be on the left side of that application in the Bootstrap layer. You have things like this, that get Twitter API key, that just returns get env, then the string Twitter API key. Code like this is not unit testable. It relies on environment variables being set in a particular way, so you just can't test it in isolation. This is true of all config loading code, no matter how you do it. You have a file or config stored somewhere. You need to load it up into your application to read it. At a fundamental level, it just can't be tested. It's untestable. It can't be unit tested. You can test it with integration tests, but you can't test it with unit tests. And the other thing you have at the start of your application is you almost certainly have a piece of code that actually bootstraps the application itself. This code is hard-coded to use a particular implementation. So again, this is like a thing that can't be unit tested. For most unit tests, you need to be able to swap out the implementation for a different class, which you just can't do for code like this. And on the right-hand side of the application, anything that talks to a database, an external API, or a file system just can't be unit tested at all. You can test those things with integration tests or regression tests or smoke tests, and you should be doing those sorts of things, but you can't test them in isolation. It's just not possible. And I said that types are the other fundamental difference, the fundamental force in programming. Within your application itself, and again, apologies to the people at the back who won't be able to read this, up here is a function. The three parameters that are passed into this function are the Twitter API, a message, and a user. Inside the function, it then formats a string and then calls the next function, send message, which just takes a string as the parameter. This code is strongly typed with a semantically meaningful type. A Twitter API has a particular meaning. A message has a particular meaning. When you communicate with APIs to the outside world, like a database or a Twitter API or a file system, you're just sending strings back and forth. Again, it's not the topic of this talk, but it's a fundamental difference that people should be thinking about. And then, excuse me, here we go. In the middle of the diagram, where you have your application code, hopefully all of this you can structure this so that it's completely unit tested. If you refactor your code to push any interactions with the outside world to the edges of your application, you can write all of your application code in a way that allows it to be completely covered by unit tests. This is not always so easy to do if you don't have the right tools. So just to show you that diagram again, just to summarize what I said. On the left-hand side, you have a Bootstrap layer where code can't be tested. In the middle, you have application code that can be unit tested. And again, on the right-hand side, you have code that can't be unit tested. So there's two completely different types of code in all applications. Having two different modes is a problem. It means that you need to be working in two different ways at once, which normally ends up with most applications mixing untestable code up with testable code, which leads to a messy application. And it also means that encapsulating external services to interfaces can be a bit of pain, and a lot of the time people just don't bother, just like in a controller connect directly to a database just because it's the easiest code to write. I think this is not using the right tools to write applications is a reason why a lot of applications become messy. Dependency injection, so long as you're using a good one, is the tool that I use to make it easy to write applications. So yeah, so ever since I've started programming, I've always tried to get better each year. But for me, a lot of techniques that people say I should be following are just too painful to use in practice. And it turns out that just for a large part, it was just because I wasn't using powerful enough tools to actually write the applications. I think a decent analogy is that trying to write solid code without using a dependency injection container is a bit like trying to do DIY at home with a knife instead of a screwdriver. I mean, technically, yes, a knife can be used to screw in most screws. It just won't work effectively that well. And in practice, it'll be such a pain that you'd abandon the project halfway through. So Auron is the tool, is the dependency injection tool I recommend people use. Disclaimer, I am listed as one of the authors on it. But to be fair, most of that was just writing the tests rather than actually making it work. So Auron is an auto-wiring recursive dependency injector, which sounds like a scary phrase. It's not really, and I'm going to break down what Auron does. Auron runs code for you. Instead of calling code yourself, you give Auron a callable that you want to run, and it will run it. So in the simplest example, we've just got a function called foo. We're telling the injector to execute foo. Sympathy coughs. I appreciate it. We've got a function foo. We're asking the injector to execute it, and because there's no parameters, it just executes it without doing anything else. Auron allows you to wire up parameters that need to be passed into either functions or classes. So here's an example of a file writer class that needs a path variable as the constructor parameter. Again, apologies to people at the back. The params are just colon path with the path of /var/coolapp. We tell Auron to define these parameters for this class, and then so the other thing is that Auron can also make objects as well as execute code. In this example, when we tell Auron to make a file writer class, it knows that because we told it what the path should be, when it goes to execute the constructor, it passes in the correct path to the class. The auto-wiring bit of the description of Auron, basically it just means that instead of having to configure everything by hand, Auron looks at the parameter types when trying to create objects or execute code. So in this example, we've got a function called write hello world that takes a file writer object as a single parameter. We tell Auron how to create file writer objects, and then when we tell Auron to execute the write hello world function, it looks at the parameters that function expects, sees that it needs a file writer object, goes away and creates that object, and then passes it in as the parameter when the code is executed. not using types or not using auto wiring is the biggest problem that the biggest problem I think a lot of other dependency injector libraries have is so that instead of using types, they require you to set up everything using service names, which makes setting up the config just be a complete nightmare. I wish I'd saved it. There was a bug report on bugs.php.net where somebody was complaining about his application using too much memory, and basically he was using the Symfony framework, and he'd been using quite a few plugins for it, and he pasted in his config file for the application, and the config file alone was a 15,000 line array of services, and he was wondering why it took up quite a bit of memory. Or just uses types. The benefit of that is you never need to set up a 15,000 line config file, but it also just makes the code be a lot more reasonable as well. Instead of having to think of service names for all of the different objects in your application, you just use the actual class name or interface name as it is in the application, which makes it a lot easier to reason about the code. For some objects, you only ever want to have one of them. In the past, people have used the singleton pattern a lot to do this, but because we're using a dependency injection container, we can just tell it, hey, we only ever want to have one of this type of object. I won't read the whole thing out. We're running out of time. So if you tell the injector to share a class, whenever the first time that Oren goes to create that object, it'll create it once. Then after that, it will use that instance that it's already created for all the other things that need it. After that, the first object will just be reused. This is actually, you can also share objects directly. So instead of telling Oren to share a class name, you can create an object yourself. Tell Oren, here is an object. If you ever need to use an object of that type, use this one instead of creating one yourself. That's actually really useful for when you're refactoring a legacy application. You quite often find that there's some legacy code doing some really, really horrible stuff that you can't migrate to a nice way of doing things. So you can, to stop your application from breaking, you can just keep that legacy horrible hack in place and tell Oren just to use this object wherever it's needed. Getting onto more powerful stuff. So Oren allows you to alias interfaces to a specific class or implementation, which means to say, in this piece of code, in the middle, we've got a function called foo, which depends on an interface called writer. We've got an implementation called stub writer that implements that interface. We tell Oren alias writer to stub writer, which so that when we go to execute the foo function, Oren understands that instead of trying to create the interface, which obviously wouldn't work, wherever something is asking for the writer interface as a parameter, to instead go away and create a stub writer object as the dependency to be passed in. This allows you to swap out implementations. So like in your real application, you'll use real implementations. In your unit tests or regression tests, you can swap out to use stubs or mocks as you want to be able to test your application. So far, so boring. Most dependency injection containers can do these sorts of things. Oren has two things that make it much more powerful than other dependency injection containers. The first of which is delegation. So I want you guys to cast your mind back to earlier in the earlier slide when I talked about having untestable code in the bootstrap layer of your application. This is another example of untestable code, where we want to be able to create a Twitter API config object, but we need to do that by reading the parameters from the environment. Auran allows you to delegate. Also, Auran allows you to create a delegate function, which means, so delegate Twitter API config with the function name means whenever Auran goes to create a Twitter API config object, call this object instead of trying to create it yourself, and it'll create one for you. This is really, really powerful. It provides the binding in your application between the bootstrap code and the application code. The other thing that's really powerful is that, as I mentioned at the start, is that Auran does the dependency injection recursively. So in this example, it goes to execute send message, sees that it has a dependency on a Twitter API object, so it goes off to create that. It sees that it has a dependency on Twitter API object, so it goes off to create that. And then sees that Twitter API has dependency on a Twitter API config object that it needs to create before it can actually create the Twitter API object, so it goes off to create that config object first. Having this recursion, having the dependency injection done recursively in Auran is really cool and really powerful. It means that you never ever need to tell Auran how to composite things together. You only ever need to tell it how to create simple objects, and then if a dependency is really high, if one class is dependent on lots of other things, it will be able to go through, create all of those individual things one by one, put them all together to create the composite object itself, which means that you never need to give Auran complicated instructions. You just tell it how to create the fundamental objects once, and then it does the hard work of putting stuff together for you. The end result of using dependency injection container like Auran is that your testable and the testable and typed code that makes up most of your application can be written really clearly. The non-testable and untyped bootstrap code is completely separated away, and the injector provides the binding between these two different regions. I've been using this pattern for a couple of years, and I thought it's going to be really easy to explain how awesome it is. Although I've explained how it works, I don't think it really shows off how good it actually is in practice. It's only when you actually start coding like this that you get to see how powerful it is. What happens is bootstrapping your application becomes really easy because you're only ever writing simple functions that do one thing at a time, and writing application code in a way that's easily testable becomes much easier as well. What the things I showed you just don't really give a really good impression. That you need to see a big application in practice. What I'll do is I'll send around an example application I've got via Twitter at some point. There's always downsides to using different pieces of technology, and there's a couple of things that occur when using an injector that don't occur in normal programming. The injector is not good when you have more than one of a type. So in most applications, you probably only have one database that stores all your data. But we've got here is a function that, to comply with the UK Data Protection Act, we need to archive data from the live database to the archive database. So we've got a function that's called archive data that takes two parameters, both of which are the same type, a connection to a database. Auron kind of just doesn't understand this at all, just because it only knows about types, and when you've got two things of the same type, it's just going to get confused. There's two different ways to work around this. The first and the simplest way of doing this, which I recommend if you've only got a couple of functions like this, is just to create a wrapper function. So we've got the original function that takes the two different connections at the start, and then in the second function we called archive data wrapped, instead of passing in the actual PDO connection itself, we pass in a PDO factory, and then inside the function we call PDO factory create live to get a connection to the live database, and then we create PDO factory create archive to get a connection to the archive database, and then call the previous function with the parameters set. There's a much more powerful solution to this sort of problem, which I recommend if you've got this happening across, if you've got a much bigger application where you've got more than one type of thing in multiple places. Pattern's called context objects. It's even got a paper about it on the ACCU. Basically, it allows you to define in your application a semantically meaningful context, which can be reused across different parts of your application. Allegedly, this pattern's used a lot in the banking world, where when you've got a bank transfer that needs to be logged in a particular way according to one piece of legislation, or you've got a different type of transaction that needs to be logged in a different way, what the programmers at the bank would do would be create a specific context for this type of transaction, a different context for this type of transaction, and be able to put the appropriate object that conforms to the appropriate to the legislation in those contexts. So for this simple example, we've created an archive context which contains a reference to the current database and the archive database, and then we can refactor the code to, instead of before we had the function was dependent on the live and archive, so the current and the archive connections, we now change the code to pass in this archive context, and we tell Auron how to create these contexts. So all the wiring's done up. So all the wiring's done by Auron, and that archive context can be reused across your application. And the second problem with using a dependency injection container like Auron is that sometimes you just can't know your dependencies. So here's a piece of code, same as before, that we want to be able to send a message to a user, but now we've got more than one place where we can send a message to. We've got Twitter, and we've also got PagerDuty. Depending on whether the user has their preference set to send a message via Twitter or PagerDuty, we'll need either a Twitter API object in this function, or we'll need a PagerDuty object in this function. And you just can't know which one's going to be needed before the functions run. This is actually like a really common problem across a lot of code bases, but one that the Symfony and Send guys just don't seem to want to recognize. I'm not entirely sure why. I think it's just that those frameworks have particular limitations in place. They don't want to advertise too publicly how those limitations affect people's code. The only sensible solution to this problem is to have multiple levels of execution. Anything else is just going to be a nasty hack. It's really, really ugly if you don't have multiple levels of execution. So I have my own framework which does this, which if people want to ask me about, it's not entirely horrible, but I don't recommend it for production yet. What you need to do is take the original function that finds out what message service the user wants you to use, and then instead of calling it within that function, tell the framework, I don't know how to run this, but here's the next thing that needs to be run. So if the user has the Twitter API set as their preference for how they want to have a message sent to them, this function returns a new executable of the function send Twitter message. Otherwise, if they've got PagerDuty as their selected service, it returns a new executable saying run the send PagerDuty message as the next thing. And the final thing actually about dependency injection is that sometimes it's just a bit too much of a pain in the ass to do properly. Auran can be used as a service locator as well. So if you ever need to just use it as a service locator as opposed to a dependency injection container, you can use it for that as well. Particularly when you're refactoring legacy apps, you've got a whole load of stuff where it's using a service locator inside the application already. So moving to just use dependency injection would be too much of a pain to do in once. That's about it. I apologise for the state of my voice. I apologise if it didn't make too much sense. Any questions?
If you have just one concrete implementation of an interface, is it clever enough to work that out, or do you need to alias it?
You'd need to alias it. Why do you only have one implementation of an interface?
Designed to interfaces. Okay. Symfony can work that out, you know.
Can it now?
Yeah. The auto wires and everything.
Good for it. More questions? I escaped. Cool. Cheers. Thanks, guys.